The Spitfire carried 8.303 machine guns. The P-47 Thunderbolt carried 8.50 calibre Brownings. Someone in the comments called the Thunderbolt basically a flying gun battery, and honestly, that's hard to argue with. Two nations, same war, same enemy. Completely different answers to the same lethal question. What do you bolt into a fighter's wings? But this isn't just about the guns. It's about the ammunition those guns fired, including a secret Belgian incendiary round that most accounts never bother to mention. It's about what those guns did to locomotives and horse-drawn columns and airfield hangars. Because the original discussion never once touched ground attack, and that's an enormous gap. And it's about what it felt like to be on the receiving end. Because the German pilots who absorbed those streams of fire, they had opinions, sharp ones. Here's the arithmetic that drove everything. A fighter closing on a bomber at 300 miles per hour gets maybe 2 to 3 seconds of firing time in a typical deflection attack. That's it. 2 seconds to put enough destructive energy into an aeroplane to kill it. Air Chief Marshal Sir Hugh Dowding, back when he led research and development at the Air Ministry in the early 1930s, worked through this calculation with his technical staff and landed on a minimum weight of fire, roughly half a pound to a full pound of metal per second, needed for a reasonable probability of a kill. 8.303 Browning machine guns, each cycling at 1,150 rounds per minute, each firing a 174-grain bullet at 2,440 feet per second, met that threshold. The early Spitfire carried 4 in each wing, 300 rounds per gun, and could put 160 rounds per second downrange, a dense cone of rifle-caliber bullets converging at a harmonization point set between 200 and 250 yards. Rational, carefully reasoned, and for the aircraft it faced in 1940, effective. The Americans looked at the exact same problem and made the opposite bet. Fewer rounds, heavier bullets. The weapon was the Browning AN/M2 in.50 BMG, a cartridge John Browning himself had developed during the First World War, firing a 709-grain bullet at 2,900 feet per second with roughly 10 times the muzzle energy of a .303 British. The P-47 Thunderbolt, which Republic Aviation would build over 15,600 of before the war ended, packed 8 of these guns, 4 per wing, 425 rounds per gun, for a total load of 3,400 rounds. At 800 rounds per minute per gun, that's 106 rounds of half-inch ammunition per second, each one capable of punching through nearly an inch of face-hardened armor plate at 300 yards. Not merely more firepower than the Spitfire's 8.303s, a categorically different kind of destruction. Same war, same maths, opposite conclusions. And that's where this story gets genuinely messy, because neither answer was wrong, and neither was entirely right. The standard narrative about the .303 goes like this: adequate in 1940, marginal by 1941, obsolete by 1942 as German aircraft gained pilot armor plate, self-sealing fuel tanks and sturdier construction. A 303 ball round, the Mark 7 174-grain full metal jacket, could punch through aluminium skin and shred control cables, but it couldn't ignite fuel in a self-sealing tank and couldn't penetrate the 8mm armoured headrest on a Bf-109E. True enough, but incomplete. Because the story everyone leaves out is a small, brilliant Belgian invention called the De Wilde incendiary round. Captain De Wilde, a Belgian arms designer whose personal history remains frustratingly shadowy, developed an incendiary bullet in the 1930s that British intelligence noticed and pursued. What made it extraordinary wasn't just the incendiary effect, it was invisible. Unlike a tracer round which burned visibly in flight and warned the target that fire was incoming, the DeWilde round contained a cavity filled with an incendiary composition, typically a mixture involving barium peroxide, that didn't ignite during flight, but detonated on impact with a hard surface, producing an intense flash of heat and a small explosive effect. The British adopted it as the Mark VI incendiary, and significant quantities were available by the summer of 1940. Just in time. The effect on .303 viability was transformative. Pilots during the Battle of Britain who had DeWilde in their belts, typically loaded in a mixed pattern alternating ball, armor-piercing, tracer and incendiary, reported dramatically different results. The flash on impact told you instantly whether you were hitting the target, solving the ancient problem of knowing if your fire was connecting. But the real gift was what it did to fuel tanks. DeWilde rounds could and did ignite aviation fuel, even in tanks with early self-sealing liners, because the intense, localized heat overwhelmed the rubber compound's ability to close around the entry hole before fuel vapor was already burning. Squadron leader Ginger Lacey, one of the top-scoring Battle of Britain pilots with 18 confirmed victories, was among those who credited DeWilde with making the difference. The consensus in fighter command was clear. Mixed belting with incendiary rounds extended the combat life of the 8-gun .303 armament far beyond what ball ammunition alone would have permitted. The standard story says the .303 was obsolete by 1941. The honest assessment? With DeWilde incendiary, it remained a genuine threat to aircraft through at least 1942. It wasn't the calibre alone that was failing. It was the increasing armour and structural robustness of German types that finally tipped the balance. And the British knew it was coming, which is why they'd already started reaching for something bigger. Remember that. It matters later. The RAF never thought 8.303s would last forever. Even before the war, the Air Ministry was exploring the Hispano-Suiza 20mm cannon, a weapon designed by Swiss-French engineer Marc Burkicht that offered something qualitatively different. A 130-gram high-explosive shell at 2,800 feet per second, capable of blowing a fist-sized hole in an aircraft structure and detonating fuel tanks with a single round. But here's the thing nobody properly explains about this transition. It wasn't just a matter of swapping one gun for another. The Spitfire's elegant elliptical wing had been designed around .303 Browning machine guns, slim weapons, light recoil, easy to package inside a thin aerofoil. The Hispano 20mm was a completely different animal, physically longer, substantially heavier, and generating recoil forces that the original wing structure was never meant to absorb. Fitting two of these cannon into a wing built for rifle-caliber machine guns required redesigning ammunition storage, strengthening structural members to handle the recoil loads, and solving the feed mechanism problem in a space that was, frankly, too small for the job. The first attempt used drum magazines, the Hispano Mark I, and those drums had to bulge outwards slightly from the wing's lower surface, creating aerodynamic drag and, far worse, a feed geometry that was acutely sensitive to G-loading and vibration. Think of it as 3 stages defined by what the guns could actually do, not by configuration labels nobody cares about. Stage 1, 8.303 Brownings, adequate against 1939 to 40 aircraft, significantly enhanced by DeWilde incendiary. Stage 2, Two 20mm Hispano cannons paired with 4.303 Brownings, appearing on Spitfires from early 1941. A compromise that gave explosive cannon punch for the critical hits, while keeping the .303s for their higher rate of fire and deeper ammunition supply. The Hispano drums initially carried only 60 rounds per gun. 60. Against 350 rounds per .303. Stage 3. Two Hispanos with 2.50 calibre Brownings, acknowledging that even DeWilde-loaded .303 was no longer enough. And the final wartime stage, 4 belt-fed 20mm Hispanos, putting roughly 40 high-explosive shells into a target in a 2-second burst. That progression from drum-fed Hispano Mark I to belt-fed Hispano Mark II was more important than it sounds. The Mark I's drum was a disaster. 60 rounds, fed by gravity and spring pressure through a curved path into the breech, and under combat conditions, that path failed constantly. The Mark II introduced a belt feed system that pulled ammunition from a box magazine along a far more reliable straight-line path, eliminated the drum's vulnerability to G-loading, and doubled the ammunition capacity to 120 rounds per gun. Belt feed also meant the ammunition boxes could be shaped to fit within the wing's internal volume, rather than requiring external bulges, which cleaned up the aerodynamics and reduced the feed-related jams to a manageable rate. It was painstaking, methodical British engineering. Not glamorous, not fast, but it worked. Progressive optimization. Always evolving, always mixing, always reaching for the next increment of lethality. Intellectually elegant. But it came with a cost that nobody likes to talk about honestly. At 25,000 feet, outside air temperature drops to roughly -30 degrees Celsius. Metal contracts. Lubricants thicken into waxy residue. Recoil springs lose their temper. These aren't British problems or American problems. They're physics problems. When 19 Squadron received the first cannon-armed Spitfires in the summer of 1940, 2 drum-fed Hispano Mark I's, 60 rounds per gun, the results were disastrous. The drums fed unreliably under vibration and G-loading. Cannon would fire a handful of rounds and stop dead, leaving a pilot with nothing in the middle of a fight. The squadron was so frustrated, they requested a return to 8.303s, and the Cannon Spitfires were temporarily withdrawn from frontline service. That story gets told constantly as a British failure. Here's the part that doesn't get told. 5 years later, half a world away, the F-4 U-1C Corsair, roughly 200 built, deployed in the Pacific in early 1945, with units including VF-85 and VMF-311, mounted 4 AN/M 220mm cannon, in place of the standard 6.50 calibre Brownings. The AN/M2 was the American-produced version of the very same Hispano design. At low altitude, against Japanese ground positions, those 4 cannon were devastating. Streams of high-explosive shells, shredding bunkers and light vehicles in ways 50 calibre simply couldn't match. But at altitude, same nightmare. Same congealing lubricants, same seizing breech mechanisms, same dead guns. Bob Whitney, a Navy Corsair pilot whose account survives through veteran interview collections, described what happened next. Ground crews and air crew rigging improvised gun heaters, essentially electrical warming elements wrapped around the breech and feed mechanism, powered by the aircraft's electrical system to keep lubricants above their congealing point during the climb. American engineers in 1945, bodging together the same ad hoc solutions to the same cannon freezing problem that British engineers had wrestled with in 1940. That fact alone demolishes any notion that Hispano-reliability was a uniquely British embarrassment. The British had already solved their side of it. The shift from drum-fed Mark I to belt-fed Mark II through 1941 and 1942, combined with improved lubricants and heating arrangements, had made the Hispano a generally dependable weapon in RAF service by mid-war. The Americans, arriving at cannon later and in a different theatre, had to learn the same lessons from scratch. Even the Germans weren't immune. The Mauser MG 151/20 on the FW 190 was generally excellent, but had documented stoppages, particularly with electrically primed ammunition variants that could misfire. The Japanese Type 99, derived from the Swiss Oerlikon, was notoriously unreliable at high rates of fire and suffered from low muzzle velocity that made deflection shooting exceptionally difficult. Every Air Force paid tuition in jammed guns and missed kills before their 20mm weapons became dependable. Every single one. So while the British were fighting through the cannon reliability curve, the Americans looked at all of this, the drum feed disasters, the lubricant freezing, the breech failures, and made their bet. One weapon, one calibre, everywhere. The AN/M2 Browning in .50 BMG was, by any measure, one of the great weapons of the 20th century. Exceptionally reliable after decades of refinement, and the ammunition it fired gave it a flexibility no single round could match. Standard USAAF belting alternated armor-piercing incendiary, and tracer in a carefully determined ratio. The M8 API round was the killer, a hardened steel penetrator core backed by a small incendiary charge. On impact, the penetrator punched through armor plate or self-sealing tank lining. The incendiary element ignited everything behind it. Which brings us to a 21-year-old captain named Chuck Yeager. Not the test pilot who'd break the sound barrier in 1947, the fighter pilot flying P-51D Mustangs out of Leiston, Suffolk in 1944 with the 363rd Fighter Squadron, 357th Fighter Group. Yeager, who'd finished the war with 11.5 aerial victories, was deeply particular about his ammunition. In his autobiography and subsequent interviews, he described his preference for loading belts with a heavier proportion of API rounds than the standard pattern called for. His reasoning was characteristically blunt. API rounds told you when you were hitting because they sparked and flashed on impact, and they were the rounds that actually set things on fire. Tracer burned out at shorter range than API and could mislead you into thinking you were missing when your invisible incendiary rounds were striking home. The parallel with De Wilde is almost eerie. Opposite sides of the Atlantic, entirely different calibers. And the men pulling the trigger arrived at the identical conclusion. The invisible incendiary round was the one that mattered most. Yeager's P-51D carried 6.50 caliber Brownings, 4 inboard guns with 400 rounds each, 2 outboard with 270, totaling 1,880 rounds. Less than the P-47's 3,400. But even the Mustang had a reliability skeleton in its closet. Those 6 guns were mounted at a canted angle to fit inside the thin laminar flow wing, and under high G-loading during hard maneuvers, exactly when you need your guns most, the ammunition belts could shift and the feed mechanism could jam. Modifications to feed chutes and booster mechanisms were introduced throughout the P-51D's service life. Even American .50 caliber doctrine wasn't flawless. Reliability wasn't a solved problem for anyone. It was a managed problem. The logistics argument, though, that's where standardization truly shone. The same .50 BMG cartridge feeding P-47 wing guns also fed M2 Brownings on half-tracks, jeeps, tanks, anti-aircraft mounts, and naval vessels across every theatre simultaneously. One ammunition supply chain. Interchangeable spare parts. Armourers trained on one weapon who could maintain all of them. That's not glamorous, but it wins wars. And nowhere did it win more visibly than in ground attack. By the spring of 1944, the P-47 Thunderbolt had become arguably more important as a ground attack platform than as an air superiority fighter. The 9th Air Force's Thunderbolt groups, roaming ahead of advancing Allied armies across France and into Germany, unleashed those 8.50 calibre guns on everything the Wehrmacht moved on the ground. Locomotives, rolling stock, motor transport columns, horse-drawn supply trains. And in 1944, the German army still moved an astonishing amount of material by horse. Airfields, flak positions, fuel dumps. 3,400 rounds of .50 BMG, much of it API, delivered from low altitude by a 7-ton fighter that could absorb punishment that would have killed anything else in the sky. The P-47 survived hits that shredded other aircraft because of its radial engine, no liquid coolant system to puncture, and its sheer mass of structural material. Pilots would come home with cylinders shot off the Pratt & Whitney R2800, with control surfaces in ribbons, with holes you could put your arm through. And they'd rearm, and they'd go back out. The British, of course, had their own answer to the ground attack question, and it's a revealing one, because it perfectly mirrors the armament philosophy that ran through everything they did. The Hawker Typhoon, which had failed as the high-altitude interceptor it was designed to be, found its purpose as a low-level attack aircraft carrying 4 20mm Hispano cannon and either bombs or RP-3 rocket projectiles. Those RP-3s, 60-pound warheads on a 3-inch rocket body, were a weapon of terrifying reputation. Typhoon squadrons operating over Normandy in the summer of 1944 claimed devastating tallies against German armour, particularly during the carnage at the Falaise Pocket in August. The propaganda was spectacular. The reality was more complicated. Post-war operational research, the British were characteristically rigorous about this, examined the actual strike results and found that rocket accuracy against individual vehicles was far lower than wartime claims suggested. Against a specific tank, the hit probability was dismal. But that wasn't quite the point. The RP-3's real effect was psychological and organisational. It forced German columns to disperse, to hide, to move only at night, to abandon schedules. The 20mm Hispano cannon on those same Typhoons, firing high-explosive and armour-piercing shells, were actually more consistently lethal against soft-skinned vehicles and supply columns than the rockets were against armour. 4 Hispanos delivering explosive shells versus 8.50 calibers delivering API. Different tools, different philosophies, both devastating against ground targets, neither quite as effective as the most enthusiastic claims insisted. The Hawker Tempest, which followed the Typhoon with the same 4-cannon armament but a cleaner airframe and superior performance, was equally ferocious in the ground attack role. Between them, Typhoons and Tempests carried the RAF's share of the tactical air war in northwest Europe, using the same explosive shell philosophy that had driven British armament thinking from the start. Get cannon onto the aircraft, put high explosive into the target. The Americans, meanwhile, were doing functionally the same job with solid projectiles at higher volume. 2 doctrines, 1 battlefield. Both worked. The original discussion of Spitfire armament never mentioned ground attack at all. That's an extraordinary omission, because the ground attack role is where both philosophies were tested in the most unforgiving environment. Low, slow, close to the guns, shooting back. Now flip the perspective entirely. What did it feel like to be on the receiving end? German pilot accounts describe the experience of being attacked by a Spitfire's 8.303 streams as being peppered, a hail of small caliber hits punching dozens of holes through the aircraft's skin, severing control cables, shattering instruments, but often leaving the aircraft structurally intact. The damage was cumulative and insidious rather than immediately catastrophic. A Bf 109 could absorb a surprising amount of .303 ball and keep flying. Its 8mm armoured headrest stopped bullets aimed at the pilot. Its self-sealing tanks closed around the small entry holes. Pilots would land and find their aircraft riddled with holes, but still fundamentally in one piece. One German pilot reportedly joked that he had not been shot down, but could no longer fly because of the weight of British bullets he was carrying. It's funny in the grim way that combat humour always is, and it perfectly captures the .303's terminal effect. Death by 1,000 cuts rather than a single mortal blow. De Wilde incendiary changed this equation significantly, but not all belts contained it in equal proportion, and not all hits came from De Wilde rounds. Being hit by .50 calibre was different. Fundamentally, structurally, catastrophically different. Luftwaffe pilots described the experience of taking fire from American fighters, P-47s and P-51s, as encountering a force that didn't just damage aircraft, but dismantled them. The API rounds punched through armour that stopped. 303 cold, ignited self-sealing tanks that closed around smaller calibers. And the sheer kinetic energy of a 709-grain bullet at 2,900 feet per second could sever main spar members that rifle caliber rounds merely dented. Not peppered, destroyed. German self-sealing fuel tanks and pilot armour were specifically designed to resist. 303 and 7.92mm fire. The 8mm to 12mm armour plate behind the pilot's seat could stop rifle caliber rounds reliably. Against .50 API at combat ranges, it was at its limit. The FW-190's more robust construction gave it better survivability against all calibers, but even it was vulnerable to sustained .50 caliber fire in ways that .303 streams simply couldn't replicate. And when the Spitfires shifted to 20mm cannon, that changed things again. A single Hispano-HE shell could do what 20.303 ball rounds couldn't, which is exactly why the British kept pushing toward cannon despite every reliability headache that came with it. From the target's perspective, the choice wasn't between good and bad, it was between two different kinds of dangerous. 8.303Es with De Wilde could kill you through fire. 8.50 calibers could kill you through structural collapse. 220mm cannon could kill you through explosive destruction. The German pilots knew the difference. They lived it. The ones who survived, anyway. But here's the messy part, the part that doesn't fit neatly into a winner's column. After the war ended, both nations converged. The United States, champion of the .50 BMG, defender of the standardized heavy machine gun, moved to 20mm cannon, the M39 revolver cannon, then the M61 Vulcan. The Korean War had forced the issue. F-86 Sabres, armed with 6.50 calibre Brownings, were struggling to deliver decisive damage against MiG-15s, which were faster, could absorb hits, and mounted their own cannon armament. American pilots were scoring hits, getting those API flashes on the MiG's fuselage, and watching the target fly away. The .50 had reached its ceiling. The Americans acknowledged what the British had recognized a decade earlier. The future belonged to explosive shells, not solid projectiles. And the British? They'd already arrived at cannon, had been there since mid-war. By 1945, 4 belt-fed Hispanos were standard and reliable, and the post-war generation of British fighters, Meteors, Vampires, Hunters, all carried cannon as a matter of course. But the British had also, quietly, absorbed the American lesson about standardization. Post-war RAF fighters didn't carry a mixture of 3 different calibers. They carried one type. 4 20mm Hispanos. Later, 4 30mm Aden cannon, standardized, reliable, well supplied. The future was heavier caliber. The British were right about that. The future was also standardized. The Americans were right about that. Neither philosophy won, both did. So what do you actually take away from this? Not, it depends, that's a cop-out. Something more specific. The British approach was vindicated in direction. The progression from rifle caliber to cannon. The pursuit of explosive shells. The understanding that a single well-placed 20mm round could accomplish what a dozen .303 ball rounds couldn't. All of that was correct, and the post-war world proved it conclusively. But the American approach was vindicated in principle. That a reliable, well-supplied, logistically simple weapon system will outperform a theoretically superior one that jams, runs dry, or requires 3 separate supply chains to keep in action. The M8 API .50 round, solid, not explosive, had no business being as effective as it was against aircraft. But effectiveness isn't just about the physics of a single projectile hitting a single target. It's about the whole system: the round, the gun, the ammunition supply, the maintenance pipeline, the training, the reliability at 3 in the morning when an exhausted armourer is loading belts in the rain somewhere in France. A young pilot strapping into a Spitfire over Kent in 1940 with DeWilde incendiary in his belts, and a young pilot climbing into a P-47 over Normandy in 1944 with 3,400 rounds of .50 BMG. They were both carrying the best answer their nation could engineer to the same impossible question. 2 seconds of firing time. Make it count. And somewhere in between, a German pilot looking in his mirror at converging tracer streams, or worse, seeing nothing at all until the DeWilde flashes started sparking across his engine cowling, or the API rounds started tearing through his wing root, knew something that transcended doctrine and philosophy entirely. He knew that the men behind those guns, whatever caliber they were firing, were trying to kill him. The fact that neither nation's answer was perfect is, in the end, the most honest thing you can say about it, and the most human. Subscribe for more stories like this.